Today we are going to cover section 6.1, inverse functions. So write your essential question: what is the inverse of a function and how do you represent it graphically and algebraically? Then paste your cutouts or copy them down, and we'll start once you are ready. So do you remember covering inverse functions last year? So take the time to read through both cutouts and then we'll start. Go and pause it once again. So an inverse function, you guys covered it last year. Inverse function of f denoted by f. This is not an exponent. It's a little negative one, but it's read as f inverse. And there should be f inverse. The inverse function will interchange the input and the output. So therefore, your input will become the output, and your output will become your input. Remember that your input are your x values, and your outputs are the y values. So your x's will become the y's, and the y's will become your x. In mathematics, inverse means the operation that reverses the effect of another operation or undoing the operation. So therefore, addition and subtraction are inverse operations, and multiplication and division as well. The functions f of x equals 8x and f inverse of x equals x over 8. They're inverses of each other with respect to function composition. So therefore, since they're inverses of each other, they should undo each other. So let's take, for example, f of x equals 8x. And let's plug in a value for x. So let's plug in a 2. So f of 2 will be equals 8, but instead of the x, we're going to plug in a 2. So therefore, f of 2 will be equal to 16. So now if we take f inverse of x, which is x over 8, and we plug in the 16, it should undo each other, and we should end up with 2. So f inverse of x of 16 equals 16 over 8, which is 2. Isn't that impressive? So therefore, it undid each other, and now that's what we did. So inverses will undo each other. Now to find the inverse function, we must follow the following 3 steps. In the equation for f of x, you're going to replace f of x by y. We are going to switch the roles. The x will become the y, and the y will become an x. And then we're going to solve for y. And finally, we want to make sure that we replace the y with the inverse notation in the new equation. So let's go through example number 1. Go ahead and copy it down, and we'll start once you are ready. Go and pause it. So to find the inverse, first we're going to replace the f of x with y. So we'll end up with y equals 2x minus 4. And now we are going to interchange the y, will become the x, and the x will become a y. Then we need to solve for y. Move the 4 to the left because it's a positive 4. Then divide by 2. That will give me y equals x over 2. We can rewrite it as 1 over 2x plus 4 divided by 2 gives me 2. Now this is the inverse, but we want to make sure that we replace the y with the inverse function or the inverse notation. And on your homework, I do expect to see the notation as part of your answer. Now let's go ahead and graph. Let's make two graphs. We're going to make one graph for the first one, for the function 2, 4, 5, 2, 4, 5. We make another graph for 2, 4, 5, 2, 4, 5 for the inverse. Or you can place them side to side. So therefore, let's go and graph on the first one, the original function, which is y-intercept is -4, my slope is up to the right 1. Positive slope, so this looks fine. This is the inverse, no, this is the original function, this is f of x. And now let's go and graph the inverse function here. My y-intercept is +2. My slope is 1/2, up 1 to the right 2, or the opposite. And that is the graph. Then according to our definition, they should undo each other. So therefore, if I plug in a 3, I end up with a 2. So therefore, on the inverse function, if I plug in a 2, I end up with a 3. And that will happen at every single point. If I plug in a 4, to 4, I get a 4. Well, that doesn't help us out, right? But if I plug in a 4, that's a 4. Let's try one more. If I plug in a 1, I end up with a -2. And if I plug in a -2 over here, I should end up with a 1. So it will undo each other. So that is whether it's graphically or algebraically, the operations will undo each other. And that will take us to example number 2. In Algebra 1, you guys saw the horizontal line test. So read through it, paste it, geometric relationship between the graphs of f and f inverse. Go and paste your 4 graphs, and we'll start once you are ready. A, B, C, D, and as well, you should have this with you. So let's go through, go and pause it if you need more time. Horizontal line test. A function f has an inverse function if and only if. Now remember that whenever you say if and only if, sometimes it'll be written down as if. Do you know what that means? What's the difference between only if and only if? The difference is that it works both ways. So a function f has an inverse function if and only if no horizontal line intersects the graph of f at more than one point. Or we can say backwards, if no horizontal line intersects the graph of f at more than one point, then the function has an inverse. So in Algebra 1, you guys saw, if you guys remember, you guys saw the vertical line test, correct? The vertical line test will tell you if this is a function or not. If it only crosses one at a specific point, then that is a function. The horizontal line test will tell you whether the function has an inverse. If it only crosses at one specific point, then it has an inverse. That's what the horizontal line test. And we'll talk a bit more about it in a second. If a function f is 1 to 1, then the graph has an inverse, f inverse. Then the graph of its inverse, f inverse, is a reflection of the graph of f across the y equal to x. So before we actually get to this, let's go and first determine, is this function is this graph a function? It is, by the vertical line test that you guys did in Algebra 1. Now the question is the inverse a function? Vertical line test tells me that it is. So therefore, it does have a function, it does have an inverse, so we should be able to find it. What we're going to do, we're going to place it right on top. And notice that I placed those two little fingers in here. So you want to be able to grab carefully that graph here. And notice I have it wrong. That should be original graph. There you go. The original graph is here. To take the inverse, we are going to flip it. And that'll be the inverse. So let's go and grab this. It should say original graph. I'm going to take a marker and I'm going to mark my graph here. Then I go into this. The inverse will be a reflection across the y equal to x, which is this line. So if we reflect it, and we're going to reflect it by taking the original graph, and we are going to do a reflection across the y equal to x, and therefore that will be my inverse. So therefore, I'm just going to copy it down, and I'm going to copy it down in red. So therefore, I have a point here and a point here. And then it finishes off over here. And I'm going to do the same thing here. And notice that's here, that's up there, that's here, and here, and here. So therefore, the graph will look something like this. And I'm going to keep it. It still goes through the x-axis. That is the graphical representation. Basically, your x's and y's will cross. So if I think of this point here, this point up here is -2 and 4. So it's going to become 4 and -2. So 4 and -2, that's 3. So that is the inverse. This point here, it is 2 and 3. 2 and -3, so it becomes -3 and 2. So your x's and y's switch. So let's try the next one. First, is the graph a function? It is. Is the inverse a function? It only crosses once, so it is as well. So let's go ahead and sketch it. I'm going to place my original graph here. Let me see if I can do a better job. Line them up nicely. I'm going to copy. It says original graph here, so therefore I'm going to copy it down. And I'm going to reflect it over the y equal to x. Right? That's a reflection over the y equal to x. I'm going to place my finger here, and I'm going to reflect it. Line it up first, and I can do a reflection. So notice that my fingers are still in the same corners. So therefore, that is the inverse. So I'm going to go and copy it down. That's the point here. Point here. Point here. Point here. And last point here. and that's a straight line, so I can make it a little easier, correct? So therefore, this is the inverse function. And remember, it's going to undo the operation. So if I plug in a 1, it gives me 4. So therefore, my inverse, if I plug in a 4, gives me 1. So perfect. So try letters C and D. Go and pause it, and we'll start once you are ready. So first you need to decide: is the graph a function? Yes. Is the inverse a function? Yes. So therefore, we should be able to find the inverse function. Now, you don't have to use this. You can actually just say, well, this is negative 2, negative 2. So your inverse will be negative 2, negative 2. This point here is a negative 1, 0. So it becomes 0, negative 1. Let's find another point. This point here is 2, 2. So 2, 2. Let's try this point here. This point here is 1 and 1.5. So it becomes 1.5 and 1. This point here is 3 and 2.5. So it becomes 2.5 and 3. Let's assume that it goes through here. So this point will be 3 and 4. So it becomes, this is 4 and 3. So it becomes 3 and 4. So therefore, this graph will look something like this. Right? So your y's becomes your x's, and your x's become your y's. So just in case you did not get this graph, or you don't have it with you, you can just switch the values. And notice that if I take the inverse, it gives me the original graph. Perfect. Now, what did you guys get for letter D? Is the graph a function? Yes. Is the inverse a function? No, because it crosses it twice. So there is no inverse for this function. The inverse does not exist. That will take us to example number 3. Now let's go and find, once again, let's go and find them algebraically. A function f is 1 to 1 if each value of the dependent variable corresponds to exactly one variable in the independent variable. A function f has an inverse function if and only if it's 1 to 1. So this talks about 1 to 1. So a function f it has an inverse if it's 1 to 1. And notice once again the word if and only if. That sometimes you guys will see it as if. That means that it works both ways. So a function f has an inverse function if it only if it's 1 to 1, or a function is 1 to 1 if and only if it has an inverse function. So find the inverse of the functions, then find the domain of the inverse. Let's go and find the inverse for this function. Let's try the first one. So let's see. To find the inverse, you're going to place 3 steps, right? The y becomes the f of x is the y. And now we're going to interchange the values. The y becomes the x, and the x becomes the y. And now we can solve it. Solve for y. Move the 9 to the right, becomes a positive 9. Then divide by negative 4, divide by negative 4, divide by negative 4. The 4 cancels, the negative cancels, so therefore y equals negative 1/4 x minus 9/4. But that is not our final answer because we need to make sure that we keep the correct notation. This is the correct notation. And notice that this is a line, correct? What is the domain for this line? All real numbers. What is the range? The range will be all real numbers. So therefore, the domain for this function is going to be what the range was, because your x's becomes the y's and the y's becomes your x's. So what is the range for this function? All real numbers. So therefore, the domain for this function will also be all real numbers. Letter B. So go through the process, find your inverse function, and then we can check your answer. Then pause it, work it out. So therefore, y equals to the square root of x plus 3. The y becomes the x, and the x becomes the y. And now we can solve for y. Square both sides, so end up with x squared equals y plus 3. Leave the y by itself, so therefore y equals x squared minus 3. But now we need to be able to replace it with the correct format, with the correct notation. So the domain for this function, it's all real numbers, right? That's a parabola. But what is the range for this function? Do you remember the range for this function? Well, let's just do a quick sketch. What would the graph look like? Just a very tiny little sketch. That's going to be at -3, 0, correct? 1, 2, 3, and then it looks something like this. Therefore, the smallest value that we get back is 0. So your range for this function is from 0. Does it include the 0? Yes. All the way to positive infinity. So therefore, the domain for this function, we have to adjust it from 0 to positive infinity. So let's go into decimals. Let's actually take the time to, and decimals does a really good job with inverses, I believe. I'm not 100% sure now. Let's see, f of x, let's try the first one, f of x, and you want to be doing this as well because you want to get used to working with decimals. And now I want to type in f to the power of -1. Let's see if it doesn't do it. No. I guess it doesn't do that great of a job. Let's type in as g of x. So notice that if you place the line y equal to x, you notice that this is a reflection. The red line, which is the original function, is a reflection across this line. And that goes throughout. So therefore this half is on this side and that half is on this side. So let's try the second one. I'll leave that one there. Let's do f of x, which is the square root of x plus 3. And this will give me x squared minus 3. So notice that we have this additional part. That's what, and to be able to do a domain here, I just do go from 0 is less than or equal to x, and that will restrict from 0, or we can say x is greater or equal to 0. That might be easier to read. And that's why we restrict the domain, because now that's the only part that we want. We don't want the other part because that's not part of the original function. So try letter C. find the inverse function. And then let's talk about the domain afterwards. Go and pause it. Try letter C. You got it? Excellent. So now I'm going to go and place the f of x change to the y. And now I'm going to change my y becomes the x, and my x becomes the y. But now I have two y's. And now, how do I solve for y? Well, in this case, my y is on the denominator. So remember, when we have fractions, we want to get rid of the fraction. So therefore, we'll multiply both sides by y minus 3. My y minus 3 is cancelled out. So therefore, I have 2y is equal to, let's use the distributive property. So it gives you xy minus 3x. How can I solve for y? That is the question. Well, in this case, I notice I have y's on both sides. So I'm going to move my y's to the left. We can say negative xy. And I cannot combine like terms, right? Because this one has an x. If there was no x in here, then I can just combine them. So what should I do? So what should I do? That is the question. How can I solve for y? Any ideas? Yeah. So in this case, they both have a y, so I want to factor out the y. And what's left behind? Y times 2 is 2y. Y times negative x. And now I can divide by 2 minus x. So therefore, y equals negative 3x over 2 minus x. And let me just to save some space, I'm going to replace the y with f inverse. So the question is, what is the domain for the new function? Do you remember the domain, the range? We're going to find the range for this function first. What is your range? Because your range is going to become the domain for the new function. So what is the domain for this? So the range, remember that this graph looks something like this. Oh, sorry, here and here, right? Not here. Well, sometimes it looks over here, but not in this case. But what is your horizontal asymptote? Because that's what we're concerned. Because the degree of the polynomial is the same, then it's going to cross at y equal to 2 will be your horizontal asymptote. So now that's going to become, your domain was from negative infinity to 2. And now union from 2 to positive infinity, to infinity. So now that's going to become your domain. From negative infinity to 2, union from 2 to positive infinity. And notice that in this case, that 2 is what makes this undefined. And if we actually take the time to graph it on decimals, the first function is 2x divided by x minus 3. So that's our horizontal asymptote at 2. Our vertical asymptote will be at 3. But now they'll switch places. So it'll be negative 3x over 2 minus x. And sometimes you'll see it. So you might notice that in this case, oh, time to run. And so you can see that that's the reflection. Sometimes they're going to factor a negative from here. So take out a negative from here. So it's going to give you h of x equals 3x divided by x minus 2. Notice that those two expressions are equivalent. So we probably want to do the same thing here. Multiply by negative 1 gives you the inverse is 3x. Multiply by negative 1 becomes a positive x, becomes a negative 2. So those two expressions are the same. Most of the time we prefer this one here. So let's go to example number 3. What is the inverse? Now, you know the shape of this graph, right? The shape is a parabola facing up. So the question is, does it have an inverse? No. It does not have an inverse. And you'll notice that it doesn't have an inverse because whenever you're trying to find the inverse, I'm going to replace this with y. The y becomes a x and the x becomes a y. And solve for x. This is a solve for y. So I end up with x plus 3 equals y squared. Take the square root on both sides. So therefore y equals plus or minus square root of x plus 3. And that will make it 9 inverse because you have the positive and the negative. Example E and F. Go and copy it down and we can start once you're ready. So those are the easiest questions, right? F function, find the inverse. So what do we need to do? We need to, for the first point, instead of negative 2, 1, it will become 1, negative 2. For the second point, instead of being negative 1, 0, becomes 0, negative 1. For the next one, instead of being 0, 1, becomes 1, 0. And for the last one, becomes 2, 1. Your domain, they used to be the y values, now are the x values. 1, let's write down from the smallest one, 0, 1, we just need to write down once, and 2. Now, I already made a mistake. Can you guys tell me what is my mistake? What did I not see? Correct. Notice that this is no longer an inverse because it has the same x value, so therefore inverse does not exist. And just make sure that you keep a little note to yourself. Yeah, I probably should have checked that first, right? How about for the second one, for letter F, for function g? We are going to do the vertical line test. We do the vertical line test to determine if this is a function, and that's a function. And I should have done that here first. But then I should have done the vertical line test, so the horizontal line test, to determine if that is a function. And at that point, I should have found out that it wasn't, that the inverse is not a function. So therefore, is the inverse a function? Yes. So let's go and find it. So let me just give myself more space. So g equal, and let me write a little smaller. So that's 3, 1 becomes 1, 3. 0, 2 becomes 2, 0. 2, 3 becomes 3, 2. And the last one, 4, 0 becomes 0, 4. Let me close my brace. And my domain, the set of all the x values, which is 1, 2, 3, and 0. I know I did not see until I realized I had 2 ones over here. Example number 4. Go ahead and paste your cutout, copy your example, and we'll start once you are ready. Definition of inverse functions. Let f and g be two functions such as when you do the composition, you end up with an x. And if you do the other composition, remember that we covered this back on chapter 1. You end up with an x. Under this condition, the function g is the inverse of the function f. And the function g is denoted by f inverse. So therefore, I want to be able to determine if g is the inverse of f. To be able to determine such thing, we need to be able to find two things. We need to be able to do the composition of f composed of g of x and g composed of f of x. Remember that this is that you're going to plug in something that you guys covered last year, f of g of x. And over here, this is g of f of x, which means you're going to plug in the g inside the f. And if the inverse, if g is an inverse of f, then we should end up with an x for both compositions. So let's see, let's find the composition. So I'm going to plug in f. If I instead of the x, I'm going to replace it with g. So I'll leave some big space plus 4. And now I'm going to replace it with x minus 4 over 7. And now I'm going to simplify. So therefore my 7's cancel. And I end up with x minus 4 plus 4, which is x. So therefore f composed of g of x is x. Perfect. Now if we can prove the same thing here, then we can say that g is the inverse of function f. Go ahead and work it out, pause it, and see what you get. So now I'm going to plug in the f function inside the g. So I'm going to write down the g function, minus 4 over 7. But instead of the x, I'm going to replace it with the 7x plus 4, which is the f function. That gives me, those cancel out, so I end up with 7x over 7, which is perfect, x. So therefore that g composed of f of x gives me x. Therefore, the g is the inverse of f. And we can actually write down f inverse is equal to x minus 4 over 7. And the last example for today. Go ahead and paste your cutout, write example number 5, and we'll start once you're ready. Go ahead and pause it. So we talked about inverses, we talked about for the inverse, the y becomes the x and the x becomes a y. So see if you can answer the first few questions. Go ahead and pause it, see what you get. So let's try the first one. At this point, you have worked out the first 3. So f of 3. Well, this is the f function, and I know that this is 3. So therefore, that's going to be, the y value is 2. You agree? F inverse of negative 2. So one of the things that you have to remember is f inverse, this is the x value for the inverse, and that's going to give me my y value for the inverse. The same way that this is my x for the function, and this gives me the y value for the function. So therefore, if I want to be able to think about the other process, this will be the same thing as f of one number will give me a -2. Do you agree? Because remember, the x becomes the y becomes the x. So the x becomes the y becomes the x. So therefore, I'll go over to the -2 on the y, even though this is the x for the inverse function, and that will give me, oh, this was a -2. Did you guys catch that? This will give me a 3. Correct? F inverse of 2, what will you get? Remember that we are looking for, so therefore this will be 3. We are looking for the y value for the inverse. So therefore I need to think, okay, f, the original function, and that is 2, what will be the x value? So the y value is 2, the x value will be 1. So therefore this is 1. And this will be on the test, and somehow people continue getting this incorrect on the test. So just be careful, and I'll give you guys a quiz next time. So let's try. Find the value of x. Try D, E, and F. See what you get, and we can compare our answers. Go and pause it. For letter D, f of x equal to -4. That means that this is your x value, this is your y. Y value is -4. What is your x value? Your x value is +4. So therefore x equal to 4. Do you agree? Right? You plug in a 4, you end up with -4. That means that f of 4 equal to -4, which is correct. Plug in a 4, end up with -4. Well, what did you get for the value of x? Let's see. Let's go, this is the inverse function. So I'm going to write down as the function f of -4. Are we looking for? This is the y, x, this is the y. So now this becomes your x, and your answer will be over here. So plug in a -4. Oh, that one doesn't show. Diaz should have done a better job. Can I go back and change it? I want to change it to your. That one doesn't show. So let's do 1. Let's place a 1 in here. So this is your x, that's your y of your inverse function. So I'm going to plug it. That will correspond to your x value on your original function. So plugging in 1 gives you 2. So therefore, x equal to 1. How about for the last one? What did you get for the last one? So we have, this is your y value for the inverse. That means that this is your x value for the original function. So that will give you 4. So therefore, x equal to 4. So this will conclude the lesson for today. Remember that I did take the time to do this because somehow this will be on your tests throughout the school year. And some of you guys will get wrong every single time. And of course, I've switched the wording on your test and the concepts. Have a great day, and I'll see you guys next time.